Hello everyone. In previous lecture we have seen the second activity, that is magnetic field due to current through a circular loop or a circular coil, and we have also seen what is solenoid and how the magnetic field in a current carrying solenoid. Now today we will see the third activity, that is the force on current carrying conductor in a magnetic field. Now in previous two activity, we have seen whenever the electric current flowing through a conductor, then it produces magnetic field. But in this activity, we will see its exactly reverse position, that is the magnetic field exert equal and opposite force on a current carrying conductor. Means in a previous two activity we have seen that whenever the current flowing through a conductor, then it produces magnetic field. But in this activity already magnetic field is there and current carrying conductor is also there. But whenever the current carrying conductor is placed in a magnetic field, then that magnetic field exert force on that current carrying conductor. Now, according to the French scientist André Ampere, he said that the magnetic field exert equal and opposite force on a current carrying conductor. So how it is possible, we will see, or how it is happen, we will see through this activity. For this, we have to suspend a aluminium rod AB horizontally between a horseshoe magnet. This is we have to take a strong horseshoe magnet and we have to suspend a aluminium rod horizontally between this horseshoe magnet with the help of the connecting wires. So this AB is an aluminium rod which is suspended horizontally with the help of the connecting wire in the horseshoe magnet. Now the magnetic field of this horseshoe magnet should be directed upward. It means that we have to put the north pole of the magnet below the rod and the south pole of the magnet above the rod. So we have to keep the north pole below the rod and south pole above the rod, so that the magnetic field is directed upward, because we know that the magnetic field lines are always directed from north to south. So here also in an horseshoe magnet, how the magnetic field lines or how the magnetic field is directed? The magnetic field is always directed from north to south. So what is the direction of the magnetic field? In this case, the direction of the magnetic field is upward, and this is the aluminium rod which is suspended horizontally. Now, when we switch on or when the key is closed, then current flowing through the conductor. Now, how the current flowing through the conductor? Now, in this case, the current flowing from B to A. Now, current flowing from B to A. So, what is the direction of the current? The direction of the current is horizontal. Now see here, what is the direction of magnetic field? Direction of the magnetic field is vertical and the direction of the current is horizontal. See, this is the direction of the current. Now whenever this is a magnetic field, so already the magnetic field is present here and a current carrying conductor. So whenever this current carrying conductor is placed in a magnetic field, then this magnetic field exert force on the current carrying conductor, and therefore this aluminium rod AB move towards left. So why it move towards left? Because the magnetic field exert force on a current carrying conductor. So as soon as the current starts flowing through an aluminium rod, the rod move towards left. So as soon as the rod move towards left, so we can say that, or we can prove that the force exerted by magnetic field on a current carrying conductor. Now if we reverse the direction of the current, now how we reverse the direction of the current? Now suppose if we change the direction of the battery, that is, suppose the battery is like this. So what is the direction of the current? Now the direction of the current from A to B. Now the direction of the current gets changed, and now the direction of the current is like this. And therefore, now in this way the direction of the current get changed. Now as the direction of the current get changed, then the aluminum rod move towards right. So why it move towards right? Because the force exerted by magnetic field, but we change the direction of the current. Initially, whenever the current, whenever this rod or whenever the current carrying rod is placed between the placed in a magnetic field, then it move towards left. In this, why? Because in that case the direction of the current is different. Now if we change the direction of the current, then the aluminum rod move towards right. That is the force. Here also the force magnetic field exert force on the aluminum rod, but the direction of the force gets changed as we change the direction of the current. So it shows that this activity shows that the direction of force on a conductor, force exerted on a conductor depends upon the direction of magnetic field and the direction of electric current. So it depends upon the direction, the force exerted on an aluminum rod or the force exerted on current carrying conductor is depend upon the direction of the magnetic field and the direction of the electric current. Now here how the direction? Now see, if this is an horseshoe magnet, this is the north pole and this is the south pole, and suppose this is our conductor, this is our current carrying conductor. So how the magnetic field is directed upward. So the magnetic field is in vertical direction, and if this is a current carrying conductor, so what is the direction of the current? The direction of the current is horizontally. So both the magnetic field and the current are perpendicular to each other. And how whenever this current carrying conductor is placed inside the magnetic field, it move towards left. So what is the direction of the force? The direction of the force is perpendicular to both the magnetic field and the electric current, because this is the direction of magnetic field, this is the direction of current, which are perpendicular to each other, and whenever the current carrying conductor placed in a magnetic field, then it move towards left, but the direction of the force is perpendicular to both of them. And therefore, how the direction of the force? Now the direction of the force is like this. So this is the direction of magnetic field, this is the direction of electric current, and this is the direction of force. Now in this case, the magnetic field, electric current and the force exerted on conductor all are mutually perpendicular to each other, like this. So this is the magnetic field, this is the electric current, and this is the force. So all these are perpendicular to each other, and therefore this activity shows that. So what represent this activity? This activity represent how the force is exerted by a magnetic field on a current carrying conductor, and it also gives the direction of force and the direction of magnetic field and the electric current. So this activity gives the direction of, so conclusion is the direction of force on conductor, direction of force on conductor, magnetic field and electric current perpendicular to each other. So the direction of magnetic field, force and electric current are perpendicular to each other, because in this activity the magnetic field is directed upward, the electric current flows horizontally. It means that it is in a horizontal direction. So the magnetic field and the electric current are already mutually perpendicular to each other, and whenever this current carrying conductor is placed inside the magnetic field, then this magnetic field exerts force on it and it move towards left, or if we change the direction, then it move towards right. So the direction of force exerted on a conductor is totally depend upon the direction of magnetic field and the direction of electric current, and therefore this activity gives the direction of force, magnetic field and electric current, and all the direction of all these three to each other. Therefore, the direction of magnetic field, direction of force and the direction of electric current is given by a simple rule, and that rule is called as Fleming left hand rule. So what is Fleming left hand rule? So the Fleming left hand rule states that if we stretch the forefinger, middle finger and the thumb in such a way that they are of a left hand in such a way that they are perpendicular to each other. What if we stretch thumb, forefinger and middle finger of left hand, stretch the thumb, forefinger and middle finger of left hand in such a way that they are mutually perpendicular to each other, then the forefinger represent the direction of magnetic field, middle finger represent the direction of electric current and the thumb represent the direction of force, like this. So this is the what is the direction of magnetic field? So forefinger represent the direction of magnetic field. This is the direction of electric current because our conductor lies horizontally. So this is the direction of magnetic field which is upward. This is the direction of electric current. So electric current may be changed. It may from A to B or it may from B to A. So whenever it B to A, then the current carrying conductor move towards left, and if it is moved from A to B, then the current carrying conductor move towards right. So the force exerted on it will be changed, but it is direct, but it is always perpendicular to both of them. So this is the direction of magnetic field, this is the direction of electric current, and this thumb represent the direction of force. So whenever this current carrying conductor placed in a magnetic field, then this current carrying conductor move towards left or it move towards right if we change the direction of the current. So it move towards left if the current from B to A, and this is the direction of the force. If it is moved from A to B, then the direction of the current gets changed and it move towards right. So this is the Fleming left hand rule. So this activity, that is force on current carrying conductor in a magnetic field, gives Fleming left hand rule, and we will see, we will write Fleming left hand rule. So it states that if we stretch the forefinger, middle finger and thumb of left hand in such a way that they are mutually perpendicular to each other, then forefinger represents direction of magnetic field. Second, middle finger represents direction of electric current, and third, thumb represents direction of force on conductor. So this is Fleming left hand rule. So what is Fleming left hand rule? If we stretch the forefinger, middle finger and thumb of a left hand in such a way that they are mutually perpendicular to each other, then the forefinger represent the direction of magnetic field, the middle finger represent the direction of current, and thumb represent the direction of force. So this is the Fleming left hand rule. So there may be a confusion. So how the forefinger represent current or magnetic field, or thumb represent force or electric current, or the middle finger represent magnetic field or current. So to remove this confusion, that is forefinger represent which direction, the middle finger represent which direction, and the thumb represent which direction. For that we can memorize like that. That is forefinger represent magnetic field. So we make an pair FM. So FM means forefinger represents magnetic field. M stands for magnetic field and F stands for forefinger. Then middle finger represents electric current. So ME. M means middle finger and E means electric current. So M represents middle finger and E represents electric current. And last is thumb and force, TF. So T represents thumb and F represents force. So if we memorize FM, ME, TF, so FM means forefinger represents magnetic field, ME means middle finger represents electric current, and TF means thumb represents force. So there may be no confusion who represents which direction. So if you change the finger and the direction, then the law totally get collapsed. So it should be the law or the Fleming left hand rule should be proper according to the finger and the direction of the quantities. So for that you can memorize these three things, that is FM, ME and TF. FM means forefinger represent magnetic field, middle finger represents electric current, and the thumb represent force. So this is the Fleming left hand rule, and it depends upon or explain with the help of the third activity. So we have seen the three main activities which are very important according to the exam point of view. So first activity we have seen, that is the magnetic field through a straight current carrying conductor, and its conclusion, that is that is the strength of magnetic field depend upon the magnitude of electric current and the perpendicular distance of point from the conductor. So these are the two conclusions we get from the first activity. Second activity we have seen the magnetic field due to current carrying circular coil or the current carrying circular loop, in which we have seen the magnetic strength or the strength of magnetic field depend upon the number of turns of wire. So if we increase the number of turns, then magnetic field get increased. If we decrease the number of turns, then magnetic field get decreased. And the third important activity is nothing but in that first two activity, that is whenever the current flowing through a conductor, then it produces magnetic field. And the third activity is actually reverse of it or vice versa of it, because in the third activity magnetic field is already present, which does not need to produce magnetic field by a current carrying conductor, and a current carrying conductor is also present, but whenever this current carrying conductor is placed in a magnetic field, then the magnetic field exert force on a current carrying conductor, and it was given by the scientist Andre and Beer. So that is important. So whenever the current carrying conductor is placed in a magnetic field, then the magnetic field exert force on that current carrying conductor, and the direction of magnetic field, direction of electric current, and the direction of force are given by a simple rule that is called the Fleming left hand rule. And according to the Fleming left hand rule, the direction of magnetic field, electric current and force all are mutually perpendicular to each other, such that the forefinger represent the direction of magnetic field, middle finger represent the direction of electric current, and thumb represent the direction of force that is given by Fleming left hand rule. So hope you understand this activity, third activity, and the Fleming left hand rule very well. According to the exam point of view, Fleming left hand rule and all the three activities are very important. One of the activity may be asked in the exam. So hope you understand this. Thank you.